particle P moves along the line OX. When its displacement from O is x meters, its acceleration is of magnitude 8 over x squared meters per second squared and directed towards O. When x equals 1, the velocity of P is 5 meters per second in the direction OX. Show that the velocity of P tends to 3 as x tends to infinity. So a bit like the last two examples, we have a situation where here's O, and when we're measuring our displacement in this direction, the acceleration is back this way. Therefore, we can write A is equal to negative 8 on x squared. And therefore v dv dx would be negative 8 on x squared. Separate and integrate. Integral of v dv is equal to negative 8 times the integral of x to the negative 2 dx. So we have v squared over 2 is equal to negative 8 x to the negative 1 over negative 1 plus a constant. That gives me v squared, I'm multiplying through by 2 as well as tidying up the first term on the right hand side, is going to be 16 on x plus some constant a. Now we know that v is equal to 5 when x is equal to 1. So that means that, substituting in, 25 is equal to 16 plus a, and that means that a is equal to 9. So we now have that v squared is equal to 16 over x plus 9. As x tends to infinity, what would happen is that this term here would tend to 0, and therefore v squared tends to 9, and since we know the particle starts here going in this direction, that follows that v tends to 3 and not negative 3.